All right, hey everyone. Is this like the millennial pause of live streaming when I set up a bunch of boomer stuff right at the beginning? Going live now. Nice. All right, yeah, streaming 1080p this time. Hopefully this is easier to see. All right, let's do this. We're recording so folks can catch up on this later. Yeah, I want to walk through today the new Frames v2 notifications. This is a little more complex than some of the previous stuff we've covered, so um, yeah, just want to walk through this end to end. I thought first we would demo the new feature. So we now have the ability to add and remove frames from your Warpcast client or Farcaster app. As a developer, you can send native notifications that appear in app to the user. As a user, you can add and remove frames, find them easily. A bunch of cool new stuff. So we'll just go over like how that all works. We'll do a quick demo using Yoink, which is one of the demo apps we've been working on, and show what the flow looks like to add and remove frames, manage notifications, all that stuff from a user perspective. From there, we will talk a little bit about some core concepts in notifications. So two important things here are how you receive notification tokens when the frame is open on the client, sort of when you're interacting client side, versus when you're receiving tokens or events over webhooks. So we'll talk about those two paths. And then just some principles for like good notification handling in general. We have a new guide in the docs for notifications, which we'll walk through. Then we'll take a quick look at the demo app, which is sort of the simple example, and then a more detailed look at the code for Yoink for this app that we're going to show right now. And then if folks have questions, we'll do some Q&A from the chat at the end, or as we go. I will try to keep an eye on chat. Sometimes I'm bad at this, but throw them in chat as we go, and I'll try to answer them as we go. Cool. Yeah, let's start with taking a look at the feature itself. So hopefully folks have used Yoink at this point. If not, you can find the Yoink channel. You can find this this frame pinned right up at the top here if you want to try out notifications and add remove frame for yourself. But here's what it looks like. Pop up Yoink. This is like a simple little on-chain capture the flag game. So within here, we'll hit Yoink. This is going to trigger a wallet transaction. I'm going to steal the flag. think we've shown most of this stuff in past demos, but here's the new thing. So at the end of this workflow, it shows you your rank, and we have this new button down here, add frame. So this is calling the SDK add frame action, which is one of the Farcaster actions exposed on the Frames SDK. And when we tap this, we're calling that, and you get this notification, this dialog that allows you to add the frame to your Warpcast client. So users can choose to add a frame. That means that it will be visible in the client somewhere. Different clients can implement this in different ways, but the idea is that if you're building a client, you should support allowing the user to go view these saved frames somewhere. So in this case, let's add it. Cool. And now in Warpcast, you'll see this new Frames button that's replaced the Explore tab at the bottom of the app. You can go find this frame from like a persistent screen where you have these saved installed frames. And we can click it from here to open it up and launch back into the app. So from the developer side, this context, right? This is a trigger context, and this is using the home URL that's specified in your Frames app manifest. Meaning we'll launch into this, we'll basically hit that route. That's kind of like the default homepage for your Frame app, which we will launch if you launch into the frame outside of a context like an embed. And in order to install, you have to have an application manifest, right? So this stuff must be defined, meaning you have to have that signed manifest we've gone over in past videos with a signature verifying who created the frame, giving it a name, providing some metadata about your app. So that's one of the requirements in order to install. Yeah, it would be nice to have a last used row for frames. We'll iterate on this. It's a little Spartan right now. As a user, you can also tap this Explore, right? This is always the first entry in here. And so we have a list of frames that have been created so far. We're adding to this. Our goal is to make this much more permissionless than current mini apps and composer actions and so forth that required Warpcast to approve. So in the long run, this is going to be pretty permissionless. Right now, we've just started by seeding this. We tried everything that's been added with a manifest late yesterday, and anything that seemed like it worked pretty well, we added to this Explore. So if you want to be added to Explore right now, ping me or Tony, or anyone on the Warpcast team. Okay, anyways, that's what adding looks like. So the benefit of adding, I mean, two benefits, right? One is just that users can find your frame more easily. And this is enough for a lot of applications, right? Like maybe you don't need notifications at all, but you just want users to be able to come back and find your frame. They use it frequently. So you can get this benefit of adding and removing a frame. You don't have to touch notifications at all, as long as you have a valid manifest, you have that stuff configured. You've set up a home route that we can launch into, then that's great. You can just add the frame. You don't need to use notifications. But the second big benefit of adding a frame is the ability to access native notifications. So you can communicate and build this kind of retention loop with your users. Okay, so let's do a notification. I'm going to yoink the flag. I guess we just did it, didn't we? Cool. So I'm in timeout right now. You can only yoink once every 10 minutes, so I'm waiting. I have this little countdown here. So I'm going to tap Remind Me here, and we're going to trigger a reminder notification, which remind me to come back in 6 minutes. We'll see if that triggers. We should have seen probably have seen a yoink notification by now too. Yeah, you can see I have some previous ones in here. Oh, I know what I did. I yoinked from the wrong wallet. Okay, let's do this. I need to yoink from my demo app wallet. Let's do that. All right, opportunity to demo a new feature. So you'll see in here, this kebab menu gives you the option to switch your connected wallet. So this was a big pain point for a lot of people. We finally built this out. You can see which wallet is connected, and you have a native interface to switch this on mobile. Okay, yeah, I was yanking from my Horsefax wallet. I need to yank from my demo wallet. Let's go. Great. Okay, we should be switched here. Let me yank now. Signing with this other wallet. Cool. Okay, I'm logged in with my dev account here. Okay, so we'll give this a minute, and we should see a native notification at some point here. If someone wants to yank from me now, please do to trigger that notification. In the meantime, let's talk about a couple core concepts in terms of sending frame notifications. So the two things I think at a high level that it's useful for developers to think about are that there's sort of two paths to receiving a notification token for the user. So the way you'll send notifications is you will get back from the client, right? In this case, from Warpcast, a notification token and an API URL where you can post to that URL to send a notification. And so that notification token uniquely identifies and authenticates your request to that API for that specific user. We'll look more concretely at like what that looks like when we get into the demo. We can look at exactly what the tokens look like. But in order to send notifications, you need to get that notification token back from the app, and you need to persist it somewhere in like persistent storage. So, Redis key value store that's persistent, or a database, or something in order to hold on to that token. But there are basically two paths through which you can get it, right? One you can think of as kind of the open path, where the frame is open in the client app and communication is happening over that client SDK. Thank you, Christopher, for yanking. That communication happens over like a post message channel between the Warpcast client and your app. So think of that as kind of receiving a token on the front end. From there, you still need to persist that token, save it if you want to send notifications in the future. But there's also a path, right? There are other ways that you can add the app to enable or disable notifications, which we'll look at in just a sec. Great segue. Okay, this should be our notification. Cool, there it is. So we got yoinked. This notification sent from the yoink backend to the Warpcast notification API, and it's shown up here in the app. You can also tap as a user. You can tap a notification. Tony yanked the flag now. So this will launch you back into the app. And we'll look at this in the demo, but your app gets the context of that notification. So when we sent that notification, we put a special ID on it. And when your app launches after tapping the notification, you get that ID back in the context. So in the case of Yoink, we're just always loading this on page, but you could do something, switch on the value of that ID and do something different based on which notification was sent. Cool. So yeah, that's the basic idea. You'll see these notifications. I have a few from the past here from having tested it out. At some point here, probably while I'm yapping, we'll get another one from the reminder that I set, hopefully. But yeah, that's the big idea. Let's also look at how you can manage notifications as a user, right? So as a user, you can also, in the app, tap this kebab. You can either remove the frame altogether, right, which will remove it from the home screen. So now it's gone. Or you can just manage notifications, right? So maybe a frame is something you still want to have on your home screen. You want to be able to find it, but you just want to mute it for a little while, or don't want it to send you notifications. So you can manage that here as well with this little toggle. The other way you can manage this is from the frame screen here. You can long press on an app, and you'll get this little pop-up, either remove from here or tap into this management view, and you can toggle notifications. So we'll probably build out more in here as there are more frames features that we build out, but that's the state of things now. Okay, so let's make sure my notifications are on and we're all good here so we can see if that other one comes in. Yeah, looks good. Uh, okay, so back to these core concepts, like the open path versus the closed path, right? Open is receiving a message over the SDK on your front end, like within your app. But these add and remove paths are the closed paths, right? So a user might remove your frame through this interface. They might do it by long pressing here and removing it. There are other mechanisms by which, when your frame is closed and we don't have this SDK channel open, the user might choose to disable notifications or remove the frame. And your app wants to know about that, right? So we also have a webhook path. So think of this as like the frame closed path. And you specify a webhook in your app manifest, and clients will hit that webhook with events when different things happen. And right now, those are all notification related. So you can get an event when a user adds your frame or when a user removes your frame. You'll also get events when users enable or disable notifications. But that's extensible as well, right? So perhaps in the future, there will be other event types besides just notifications. But that's how it works right now. The WordCast APIs on the client side, APIs are designed with pretty good defaults. So you can optionally listen to webhooks. If notification token has expired, we will just skip the notification, and we'll give you back some data in the response saying that notification was skipped. So you don't necessarily need to implement webhooks, but I think for the best UX, it's a good idea because you'll want to know when users are subscribing and unsubscribing, so you can add or remove notification tokens for them. It just provides a better UX in most cases, and it's also more efficient for your app, right? Like you don't want to be persisting a bunch of notification tokens for notifications that you don't need to send. So we do strongly recommend implementing that webhook and listening for these events. Cool. Yeah. So because Yoink, I expect that we should get that. Christopher says he cycled the app frame to see if it'll trigger notifications. So because Yoink is listening for these webhooks, these events, we should get the notification for that timer that I sent, which is probably coming up soon. But we'll see. And that's because we're subscribed, right? Like even though I've added and removed the frame, triggered and disabled notifications a couple times here, we should be in sync with the latest token if all that stuff is working. Cool. That's the demo. That's core concept number one. Yeah, thing number two, I guess, is just some principles for handling notifications. I think the two big ones are, zooming out from those principles, I think notifications are a powerful tool for building retention loops with your users. You can also lose, I think, a lot of trust with those users if you abuse them or if you have buggy notifications and send out a lot, right? Send duplicates. So use them wisely. Be careful with them. Users always have the ability to remove your app or disable them from the client and kind of take that ability away from you altogether. So certainly design your systems around that possibility, right? That notifications may not be deliverable if the user has removed them. And I think think carefully about how you're implementing this and try to avoid being too annoying with what you're doing with notifications. And the two big things that I think are important in terms of handling notifications are, one is deduplicating and creating idempotent notifications, right? So if you happen to send the same notification twice or retry, make sure that you're deduplicating so you're not accidentally sending multiple identical notifications. Good ways to do that are using a correlation ID or unique ID in every notification that you can check to ensure that you're only sending it once. And I think stepping even further from this, like in Yoink, I use this tool QStash, like a message queuing system, which is a pretty good demo tool. I think just drop into Next.js, like a Redis-based queue system that handles a lot of these guarantees that you'll want out of a notification system. Things like only once deliverability and deduplication and idempotency and stuff like that. So a good recommendation from me is I think use a messaging system, a queuing system, or background workers or Redis or something to manage these notifications in a real live production system. yeah, principle 2 is handling retries, right? So just handling all the error cases that can happen with notifications, which is things like timing out, things like expired or invalid tokens, and making sure you think carefully about all those edge cases in your notification design. So my strong recommendation is to use like a messaging system or a queuing system that can give you some of those guarantees out of the box. But also, if you're just building this yourself on top of something like Redis, think about those principles. Okay, let's look at the docs. So we have this new guide. This is here in the frames docs. So if you go to docs Farcaster XYZ, jump down to frames, we have a new section here on notifications and webhooks, which walks through all this. And yeah, let's take a look at it in order, and then we'll take a look in the demo app. So to successfully send a notification, you need to have a valid domain manifest. You need to prompt the user to add the frame. You can do this by calling the add frame action from the SDK. That gives you back a notification URL. That's the notification callback URL and a notification token. You'll want to save those to persistent storage in a database, in durable Redis, somewhere you can access that later. And then from then on, you can send notifications by posting to that URL using that token. URL is abstracted here, right? Because there are multiple Farcaster clients, right? We're designing for a world where there will be multiple clients that have different APIs for this. We're also probably designing for a world where there are third-party services that are delivering URLs, right? So someone like Naynar is likely to provide a notifications API that multiple clients or other people can use here. So as of today, I think Warpcast is the only one that has implemented this, so these will always be the Warpcast API. But in the near future, this will be other clients as well. Yeah, and then step 5 here, make sure you're listening to webhooks that tell you when users are adding or removing the frame and enabling, disabling notifications. So domain manifest, we've gone over this in previous videos, so I'm not going to spend too much time here. But yeah, domain manifest is this file. You serve this at the root of your frame application subdomain. It has a signature in here that verifies your Farcaster account ownership of this subdomain and some metadata about your frame. So stuff like its name, the splash icon, and most importantly here are these two attributes. One is this home URL. This is the path within your frame app that we launch when you launch out of the app launcher page, or actually out of any context that that's otherwise unspecified, right? So that would be out of the app launcher, but there are probably other contexts in which maybe we'll enable the ability to launch into a frame. And if we don't know which URL to use based on other contexts, we'll always use this sort of homepage URL. And then your webhook URL, which is where you're going to receive events from clients. So yeah, follow the guidelines in here to make sure you've set this up. I have seen like out there on the timeline, I've seen a bunch of really good, interesting frames that have not set this up. So I really encourage everyone to go do this. Follow this quick guide here. It will associate your Farcaster account with it. You'll get a nice title, and users will be able to persist it and save it. So I think it's worth the 10 minutes it takes to set this up. One thing to go over here is where to find the tools for this. So these are in the dev tools. Settings, developer, make sure you've turned this on in your settings here. And then domains. So enter your domain here or your subdomain, right? If you're on like, it's a Vercel app or something. And tap this check domain status to verify it. One thing that's come up a couple of times, we will improve the messaging and layout on this, this dev tool. But this button is what also rescrapes your domain manifest if you've made a change to it. So if you have made a change to this, like come back in here and re-verify it. Every time you tap this button, Warpcache will rescrape that and store it. Don't know what happened there, but there we go. So yeah, a couple of people bumped into this. Just make sure if you need to bust the cache, come back into this this domains tool in the dev tools and update your manifest. Cool. Okay, so adding the frame to your Farcaster client. This is coupled, by the way, right? So as we say here, we always enable notifications when a frame is added right now. So there is no like second step for prompting the user to enable or disable notifications. At least for now, like adding a frame, you get notifications by default. You can go turn those off as a user. So we're trying to keep that pretty simple. Like we mentioned, there are two ways that you get these tokens, right? One is the return value client side when you call the add frame method on the SDK. The second one is over a webhook, and we'll look at both those options in a sec. Here's what the response type looks like when you call this from the SDK. So you'll get back whether it was added. If it was added, you'll get back this notification details object, which has the callback URL and the notification token. And then there are a couple ways this can fail. One is if you call add frame, but you haven't set up your domain manifest, you are not allowed to do this. So you'll get this invalid domain manifest error. The second thing that can happen is the user can reject it, right? They can click, no, I don't want to add your frame. And you'll get back this rejected by user error reason. So you can switch on these to check what has happened in the client. Okay, yeah, final important concept here is that you can only prompt the user once while the frame is open. If the user rejects it once in the session, let's try this. You remove it. So if I say not now here, I'm actually not allowed to prompt the user more than once in this session, right? And so we just want to prevent apps from spamming add frame requests here. Next time I use the app, you can ask me, but it's basically once per session. The app gets the ability to ask the user to add it. So if the user rejects the request, like subsequent requests will just get back this error rejected by user. Okay, so we got a notification token over the SDK. We persisted it in our backend somewhere. Once we have this, now we can post to this URL, post to Warpcast in order to send notifications. So we have a schema you can use in here. This is exposed in the frames package as well. So you can use these to validate your requests yourself. We're trying to export all this stuff in the frames packages so it's easy to find and use. But yeah, you'll need to provide, when you send a notification, a unique notification ID. This can be any string right now, max 128 characters. If you don't have a notification ID, like a UUID is a good choice for this. Maybe in your app you have a meaningful ID for your app. Like in Yoink, for example, we're using the Yoink ID is the block hash and position in the block, which is like the default ID from Ponder Indexer. Or for reminder notifications, we're using just the timestamp of the reminder in the user's FID. So maybe you have like a key that makes sense naturally for your IDs. You can use that, or just use something like a UUID that's guaranteed unique. You can provide a title and body. Target URL is the URL that will launch in your frame app when the notification is tapped. And then you can provide an array of tokens here. And the idea with this array is that you may want to deliver like a broadcast message to multiple users at once. So you can put up to 100 tokens at a time in here to deliver the same message to multiple users. Depends on what type of notification you're sending, right? Maybe it's a broadcast, you want to send it to many at once, or maybe the body and title contain user-specific information, in which case you just send a single token to deliver to one user. Response from this API is an object that gives you some information about what was delivered, right? So get an array of all the tokens that were successful, an array of the tokens that were invalid. So those would be tokens where the user has disabled notifications or removed the app since last time you persisted the tokens, an array of tokens that were rate limited. So I forget, this is in the docs somewhere, but we have rate limits on the number of requests you can send per user per period, right? So this prevents spamming, 5 or 6 or 7 requests in rapid succession. And also is a little bit of protection against like just buggy implementations, right? Like if you try to send the same notification multiple times, we'll rate limit you and catch that. Okay, final thing in here is listening for webhook updates, right? So we've specified this webhook URL in our manifest. This URL is listening for incoming post events from clients, telling it when users have added and removed the frame, when users have enabled and disabled notifications, and then needs to process and handle those, right? Like either deleting or creating notification tokens, maybe changing some state in your backend. The one concept here that is probably most challenging in setting this up is that these webhook methods use assign message for authentication, right? To authenticate the message, right? So this webhook is public. Anyone can post to it. We need some mechanism for you as the client app, as the frame application dev, to verify that this is like a valid request coming from someone into your webhook. And so we provide this JSON Farcaster signature. This is a new spec that we opened an FYP for that Tony put together. This is basically an extension of JWS. If you ever use JWTs, JWS, JSON Web Signatures, are the signing method for a JWT token, but it's just a scheme for signing over JSON data with a Farcaster key. And the cool thing about this is that it's like a formalized spec that will support both signing with the custody address, right, the ECDSA custody address, and with app keys, right, with your Warpcast signer or your Supercast signer with apps that have a delegated key. So we have the scheme defined in here for both of those. In the frame case, these webhook events are app key signed. So you'll use the app key scheme for verifying this. We're working very actively on a package that will make this a lot easier for you. So you can just plug in like a Nanar API key or Optimism RPC URL and be able to verify this without needing to worry about like the details of the signature scheme and how this all works. So ultimately, this is going to be really useful, I think, because it's a sort of standard mechanism for passing signed data payloads that can be used in a bunch of different contexts, right? So maybe if you're built on Warpcast, you've already used some of the API endpoints, like for direct messages and stuff that are already signer authenticated. This is kind of a generalization of that standard, and it's a scheme that we can use in a bunch of different places. So kind of technical here. If you're just building a frame, our goal is that you don't need to worry too much about this, but hopefully also something that's exciting for people because we now have a pretty good standard here for passing signed data that's interoperable across apps. Okay, anyway, so yeah, we'll talk through this when we go look at the code, but yeah, some steps for like how to grab that signature out of the payload and then verify that when you're handling a request in that webhook, it's actually legit. And then you'll get a bunch of different types of notifications. Well, 4 different types of notifications. Frame added, when a frame is added. You get a payload that looks really similar to what you get back from the SDK with this notification details object. So your callback URL and your user token. When frame is removed, it's just removed. You probably want to delete the token out of your backend. Similarly, when notifications are disabled, maybe you might want to not delete the user from your backend, right? But just delete their notification token. And when notifications are enabled, you will get another token. And these are fresh tokens on every every change, right? So if it's disabled and enabled, you'll get a new token. Replacing hub frame validation. Yeah, no. Yeah, frames v1 is just going to stay the same. We're going to keep using protobuf messages. Okay, that's the docs walkthrough. Let me put this in chat. Let's go look at what this looks like concretely. I know this was just a long, a long docs reading. Let's grab the demo app here. Okay, so yeah, this demo app repo is meant to be a pretty good starter kit if you're just starting to build a V2 frame. So this should be forkable. You can pull this down and use this as the basis for your own frame application. And we have sort of minimal notifications set up in here, but I think like generally good practices for handling them. So this is a good simple reference implementation if you're just looking at like for an example of how to implement some of this stuff. So let's look at it. Since last time we looked at it, we now have, here we go. You'll see an add to client and notifications section, which shows a button in here which will prompt you to add the frame. I've already added this. Like you saw, I launched it from the launcher, so it's disabled right now. And also a button that will send notifications. I'm going to remove this frame so we can walk through the whole thing. Okay, we should probably handle that. Okay, yeah, I have no save frames here. Oh, I need to go find it though. It's in the DevTools. Okay, so yeah, you can find this demo from Developer Tools, Frame Playground. Cool. So let's look at the code. We'll pop open this. Demo component, and let's find where we're actually adding the frame. So here's this button, add frame to client. We have this add frame callback defined somewhere up top. Let's go find it. Here it is. Okay, and when we click this button, add frame to client, we're invoking this this callback over here. So yeah, we are just calling SDK actions add frame, this action that's exposed on the frame SDK. We get back this result, and then switch on this result based on the type of response we get back, right? If we have notification details in that result, that means we got back a success case with a token, so we can set them. In this case, we're just setting them in component state. Otherwise, it was a failure, right? We're just going to display that it wasn't added. So let's do this here. There's the prompt. Okay, and yeah, here we're logging this result. So we got a token, and we got back this URL, this endpoint that we're going to hit to send notifications. Cool. So from here, we can hit this send notification button. In fact, actually, I think I should have got one because this sends a notification by default when you add the frame. Yeah, there it is. Okay, so there's the notification saying, hey, the frame was added to your client. Actually, don't know where we send that. Okay, here it is. Cool. So we're actually sending that notification through the webhook. which we'll look at in a sec. But here's where that notification came from. The webhook received this frame added event, and we sent it from here. So we're not sending it based on a user clicking a button or like a use effect or something in this demo component. We're handling that through the webhook, which I think is a good practice. That makes sense. That's going to be more reliable than like doing it client side. Okay, so I'm going to tap this. This should open the demo again. And we can also tap this to send a notification. And before I tap that, let's look at the callback here. Oh, good, it's right here. So we are sending this one from the client side. Oh no, we're not. We're posting to our own backend API to send it. But yeah, here we go. So tap this button. We're going to send this notification. We'll make a post request ourselves with the data we care about, the user's FID, the notification details object that we got back. That's going to be the token and the URL. And then we've got this send notification route on our backend or our next API. So yeah, we're going to post in the body of this request the FID and the nested notification details. So that'll be the URL and token. Here for the demo app, we are going to store these. We'll go drill into that in a sec, but we're storing these in Redis. And then we'll send these through these helpers. So we've extracted some helpers. You can totally fork these and use these yourself. These are things you can use and extend in your own frame application. But yeah, here we go. We're going to trigger notifications as test notifications sent at time. All right, so let's do it. There it goes. We got success, so we should see it in the app. Yep, there it is. If you play around with this, you can also trigger some exceptional cases. If I hammer this button, I'll get rate limited. There you go. I'm trying to send too many in too short a period of time. We can also do stuff like disable notifications and try again. So in this case, it'll succeed, but I shouldn't have received notifications. Yeah, and I didn't. Okay, that's good. Okay, so yeah, now it's been disabled. But yeah, in that previous case, right, I disabled it. We were still firing these notifications from this endpoint. I don't think we can see it easily in here, but if we looked at the response, we would have been getting back in that response body, like skip notification tokens, right? So by default, these APIs kind of do the right thing. If your token has expired, we're not going to deliver the notification. If you, as the calling app, though, care about that, you can look at the results of this request that you're making, and you'll get back which tokens were valid, which tokens were rate limited, which tokens were removed or expired. Okay, last thing here, we open this up, and you might notice this is disabled now. So one more useful utility that you have access to as a developer is that this is in the context. So we've added information about the client context to the context that you have access to through the SDK. So upgrade your SDK packages to the latest version if you want access to all this stuff. But this is useful, right? So you have this client entity in the context now with the FID of the client. So this is Warpcast 9152, whether or not the frame has been added. And if you have a notification token, you'll get back your notification details. Because I disabled notifications, I don't. So let's turn that back on. Let's open the frame again. Cool, and there it is. In context, I now have this token and URL. So yeah, as a frame dev, this is one more place you can look basically to see quickly, has the user added your app? Do they have a notification token? And in, I think, some simple use cases, you may be able to just rely on this rather than like tracking notification state yourself if you're just sending very infrequent, very simple notifications. But yeah, for more complex apps like Yoink, which we're going to look at, you want to manage that stuff and store that persistently on your own side. Oh, there it goes. Okay. I guess we're sending a webhook notification too. Let's go look at this. I hadn't seen this path, so let's go. This is a good thing we can explore here to go see how that's set up. Let's find ding ding ding. Okay, so drilling a little bit deeper in this route, like the way we're sending a notification in this demo app, we're posting to this backend route. This backend route is doing two things. It is storing the notification details when we post to it, and then actually delivering the notification. Let's look at both of these in turn. Okay, so set user notification details is really simple. It's in this KV library. We have this connected to Redis. We're using Upstash, just a simple simple Redis as a service tool. And yeah, pretty straightforward here. We have a key. We are just persisting the user's notification details in Redis as, what are we doing here? Stringified JSON. I think this handles automatically stringifying JSON objects, right? So this this notification details object is a JS object, yep, with a URL and token in it. And so we're just like stringifying that, storing that in JSON under this key, keyed by user FID. So yeah, that's stored. We can go look that up when we need it to send a notification. Second thing in here is this send frame notification helper function. So this is managing the actual interaction with the Webcast API. And we have this module under libnotifs. You can use yourself. Feel free to fork this and extend this. But this handles, abstracts over and handles interacting with the Webcast API. So this will handle results like there's no token, you've been rate limited, some error occurred. But yeah, here we go. When we send the notification, we go look it up out of persistent storage. So in this case, this is going to go use that key value store. You could use any other durable persistent store for this. Look it up from a relational database, look it up from a file on your local file system, whatever. But use some persistent store to get this back. If you don't have those details, we'll error with no token. Handle sending the actual response. So here's where we'll actually interact with, in our case, the Webcast API. But this will abstract over, potentially other clients in the future. Here's that notification body format we looked at earlier. A unique notification ID, notification title, body, the URL that you want to launch into when the user taps it, and the user tokens to deliver this notification to. Yeah, and then handling the response and any errors that we get back. Okay, so that's basically the open frame path, right? The path for sending a notification when the web view is open and you're communicating over the SDK. Let's look at the webhook, right, which is the second component, which is kind of the closed path. So how are we handling these notifications, including this one, right? Like this one came from this closed path. So let's go track this down, this ding, ding, ding notification, and look at how we got that. So that's all happening over the webhook. We have this here in API webhook. So let's look at this route. We're using some of the same primitives, right? We're using our interactions with reading, deleting, and setting notification details, and our helper to send notifications. But yeah, we have some other stuff in here. Most importantly, we have this Farcaster signature verification. So this is where we're kind of getting into the main boss of notifications, which is that signature verification step. But otherwise, your webhook, besides verification, your webhook is pretty straightforward. You'll get a post request from Warpcast when these events happen. This has a JSON body, right, with some data in it. Here's where we're handling verification. Let's drill down into this in a sec, but we'll skip that for now. Just assume that succeeds. From here, you have a data payload. It's base64 encoded, so we need to decode that. And then down here, we just switch on these events. And yeah, take whatever action is necessary based on whatever webhook event we received. So if the frame was added, we are going to grab the notification details, meaning the notification token data out of that event, save it, and trigger this, hey, you added the frame notification. If it was removed, we're going to delete their notification token, clear them out of our backend. If notifications were enabled, here's where that notification was triggered concretely. Set the token, send a notification. And then if you've disabled notifications, we'll delete it out of our persistent storage. Okay, last thing in here is the verification step. So let's take a look at this. There is a helper. Oh, sorry, wrong. Verify Farcaster signature. So there's another helper library here. You can feel free to copy, use, and fork, which is managing the signature verification. But let's walk through how this all works. This is the probably most complex part, and hopefully a week from now, most developers are not going to need to worry too much about this. But I think useful to go through the principles of how this all works too. So let's maybe go look at the FIP for a sec. So these signatures are a JSON object with this structure. They have a header, which is base64 encoded data, a payload, which is base64 encoded data, and the signature, which is base64 encoded data. CompuSophie asks, using Privy to connect with Farcaster, do we need to create a signature from a user's signer? No, you should never. Yeah, no, you're never going to create these as a frame app developer. You're only going to verify these as an app developer. So it will be right now Workcast that's generating these and sending them to you, or possibly other Farcaster clients. But if you're just building a frame app, your job is to verify the signature, but you don't need to worry about constructing it, unfortunately. Yeah, so these are JSON objects. They have this header, payload, signature keys inside of them. These two are base64 encoded JSON data, and this signature is just base64 encoded bytes. To verify these things, we basically need to do, I guess, three things, right? We need to decode the data that we care about out of this structured format, the header, the payload, and the signature. We need to verify the signature. So you need to make sure that the signature is valid, right? So it's an depending on which scheme was used, it's either an ED 25519 signature, an EDDSA signature, or it's an Ethereum key signature, an ECDSA signature. In the case of these webbooks, it's always EDDSA. So you need to check that the signature matches, right? That it's a valid signature. You also need to check that the signer associated with the signature is valid, right? So those two things are like inseparable. Whenever you're doing auth with these or doing Farcaster auth, you need to do both these things, right? You need to check that the signature is valid and that the person who the key that was used for that signature is a valid key associated with this user. And that's what we're doing here. So I don't know, we can go quick through this, but like we are decoding this information, this base64 encoded data out of the header. Here's the header. We're also decoding the signature data. EDDSA signatures need to be 64 bytes, so we're checking that. We can bail here, it'll be invalid if it's invalid length. The header provides information about which FID signed it and which key signed it. If you've used JWS or JWT, this is really similar to how that works. Here is where we are verifying both that the signer is valid and that the signer is is active, right? The signature is valid and the signer is active associated with this user. So we have a helper we wrote here that is using Nanar to do this, which is probably the simplest way for most people to get up and running with this. Another option, and we'll probably build this, we potentially will build this into the SDK, I don't know, is to go use the on-chain contracts, right? So to check if a signer is valid, you can actually go look at the key registry contract and check that this for this user, this public key is stored. Oh, here we go. Okay, good. Here's where we're verifying the signature too. So we did one first and then the second. First verified that the signer belongs to the FID and then verify that the signature matches up. And then if that all works, we can return success true and this is verified. As frame host, yes. If you are the frame host, i.e. the Farcaster client, yes, you would need to sign these messages to interact with webhooks. But as a Farcaster client, you should have a signer for the user, right? You could do that through Nanar managed signers. You could do that by just the normal Warpcast signer request flow, or just generating a key and adding it directly on the contracts. And yeah, sorry, to be clear there too, by frame host there, I mean like the Farcaster client application that is displaying the frame. Like you're probably not that in most cases. You're probably the frame application. But maybe you are. I don't know. I don't know what you're building. Okay, anyways, yeah. Point here, you can go grab this. So that's how it works, but you don't have to worry about this. Just go grab this code from the demo repo to verify a signature. You can do this. And we'll probably upstream this into the frame SDK pretty soon. But yeah, hopefully that builds the kind of the intuition behind what's happening there and how that works. Concretely though, if you're using this helper, you can just call verify signature and check whether it's true or false. Okay, that is the simple path. Jen asks, is there auth in the frames yet? No, the context is still, user context is still unauthed. So it's coming. We know lots of people need this for lots of reasons, but it's coming. We're still figuring out exactly what the right interface is there, how it will work with sign-in with Farcaster, a few other things there. So yeah, open to like, we're definitely interested in hearing what people want to do and understanding how we can make this as easy as possible. And this Farcaster signature method is actually something we might leverage in terms of the way that auth could work. Yeah, exactly. Tony says we want it to use sign in with Farcaster, but we want to make that work everywhere. And we have seen a couple apps like using Privy, especially, right, who are already signing in users with Farcaster, right? And so right now, I know the frame experience kind of sucks because you launch into the frame. We already should have your Farcaster identity, but you need to prompt users to do that again. And right now, deep links out may or may not work. I think they don't work in that context. And so that kind of sucks. On web, you'd be prompting them to like scan a QR. So we want to get to a place where that's really seamless and easy. But TBD, we're actively working on that. Okay, I think let's leave it here for looking at the demo. Just one more reminder, if you want to find this and try it out yourself, like if you're looking at the code and want to reference, you can find this in developer frames, tap this button, and it will pop up the demo. Okay, cool. Let's take a quick walk through Yoink. How are we doing? An hour? All right. So Yoink is a little more complex. I noticed we never got my reminder token. I'm gonna try to trigger that one more time. It may have been because I don't know. May have been because I um, deleted my token in between. That shouldn't be the case because I think we're handling events, but let's see. So I'm gonna Yoink again here. Let's see if we can trigger a reminder notification. Change wallets. Cool. All right, let's see if that fires. There's my Yoinked notification. We should get one in 8 minutes for my reminder. Okay, so Yoink is a little more complex. We have for a couple of reasons. One is that it's both a frames v1 and frames v2 application. So it has a um, both a v1 frame and a v2 frame together. The subpath within Yoink that we want to look at is this frames v2 subdirectory. This stuff in frames is for the v1 frame. And then some of the APIs and some of the helper code here. This looks pretty similar to the demo app in a bunch of places. Chris's code in the demo app is nicer. Actually, I'm going to pull some of that back in. We were working simultaneously on this, so I would pull in. If you're looking for a foundation for your own repo, I would use some of the code that you wrote in there. That's doing stuff like the notification delivery. This is a nice little helper. The Farcaster signature verification. These are both really useful libraries. So I would use those as the basis for your own V2 frame. But yeah, let's look in Yoink at how this works. And there are two paths in Yoink, right? Maybe let's start with the one I just showed, which was interacting with the button here. So when I'm in the cooldown mode, tapping this button to trigger a remind me notification. So that's like the open path, right? Like the user interaction triggering that notification. But we also have paths where we're delivering notifications every time the flag is yoinked, right? Which are just happening on our backend behind the scenes. So we can look at how that's set up and how that works. Okay, so yeah, here's the component that adds the frame. Similar to what we looked at in the demo. When we add the frame, we trigger this callback, handling all the different cases that can happen here. We call add frame, we get back the notification details, and then we post those details to our backend API. I am not following best practices here, which are followed well in the demo app. So this is something I need to go fix up. You'll notice I'm not posting the URL. I'm always using the Workcast API. So that's a bad practice. I should be assuming that API URL might be different token to token, user to user, because they may be using different clients. So key point there is don't do what I'm doing here. You should actually save that. So I'm going to go back and update that shortly. But yeah, really similar pattern here, right? When we get the notification token, we're posting it to our backend and persisting it. And then we're handling, in the UI, these different cases that can happen in terms of the SDK response. Maybe it was rejected by the user. We need to show them a toast. Maybe my manifest was invalid. All those cases handling here. Here's that API route. We are just storing it in Redis. Really similar Redis setup here, setting the notification token. When we subscribe to send a reminder notification, we're hitting this remind button component. So that's this one here. And in this case, we may have just added the frame, right? So if you hit this without having added the frame, we'll trigger you to add the frame first. If not, we already have a token, we will hit this schedule reminder endpoint. And from here, yeah, so from here, what I'm using is this tool called QStash, which is built on top of Upstash. It's like their managed queue service. And it's a pretty nice tool that drops directly into Next. So it's really easy to get queuing and messaging that works pretty well with your existing Next application. And we already were using Upstash for Redis in here, so it's easy to add this as well. Yeah, good option for demo and has like pretty sane defaults in a bunch of places. So what this will do is basically send a message over the queue. The way this works is you basically give a callback URL, like a callback endpoint into your application, an API, that QStash will go back and invoke when the message is delivered. And it provides a bunch of, the features or like guarantees that you want out of a messaging system. So one thing it provides is scheduling. So here we're setting this not before, which says deliver this message on a schedule rather than immediately. So within here, we've calculated when my yoink cooldown ends, and we are pushing this message into the queue with a delivery time, right? Which will say, go back and call this callback endpoint with this data at this time. And we're also providing a message ID, right? So this is important too. You can see the message ID is a unique reminder ID. This is going to be the FID of the user and the Unix timestamp when the cooldown cools down. So that will be unique per notification. And that ensures that this has a unique ID that can be deduplicated. So the queue will reject additional messages that have that ID, which in the serverless context is like important, right? Because maybe there are a bunch of different edge case scenarios, right, where maybe two things can trigger this route at the same time. Or even, you just like, mess up your React component and you're like hitting this endpoint 1,000 times. So always make sure you're like using some sort of correlation ID or some way to deduplicate your messages, which we're doing here. This tool also provides like content-based deduplication, which actually I tried first, but wound up using a explicit message ID. It was probably, bug was probably in my code somewhere rather than theirs, but wound up setting explicit message IDs, which were more reliable at actually deduplicating the messages. Okay, so think of this, right? This goes into the queue, eventually gets delivered. So when the queue pulls this out of the other end, right? At the time it's set to go deliver, it goes back and hits this process reminder endpoint. And here's where we're sending this notification. So a couple things here. This is actually a really similar pattern to our webhooks, right? With the upstash queue, they provide this function verifying the signature. This is just a middleware. We wrap our handler in this middleware, and this will verify. There's an environment variable I set which has the secret credentials to verify that signature. But they're doing the same thing that like we're doing in the webhook, right? They're providing a signature. We need to verify it when they call back to this route. And that puts some author on this route, right? So that only QStash, only this queue service can call back into our handler. Maybe it's worth concretely looking at the QStash dashboard, actually. Let me show that real quick. Here's the Yoink QStash dashboard. So we have a few things going on here. Yeah, we've sent 1.9 thousand notifications. We have one scheduled job, which we'll look at in a sec. This is what's actually sending the Yoink notifications. Here's the event stream. Nice. Here's a process reminder 10 minutes ago. Was that me? It wasn't me. This was probably me when we triggered that reminder notification. Anyways, yeah, here's what it looks like when we're scheduling a notification. Here are some that are running on a schedule. So every minute we are processing the Yoink notifications. And then here are some messages that are being delivered. And I'm using just like the default kind of out of the box messaging here. So we don't even have like specific queues or priority queues. It's just all going into an event stream. But you have the capability here to set up, pretty sophisticated messaging and retries and all that good stuff if you want. This is also like just a really easy one to use out of the box. I think it was a simple thing to choose for this demo, but there are like tons of messaging tools, many of which sit on top of Redis that you can use to do this yourself. Okay, so here's that callback. We're getting the user's notification token, handling the case where maybe it's expired. If we have a notification token for the user, we're going to deliver this notification. Yeah, okay, so that's the path for a reminder notification. Oh, look, it's time to Yoink. Okay, let's see if we got it. Nice. Okay, that one works this time. So yeah, I think it must have been because I disabled notifications that I didn't get the previous one, or maybe there's a bug in my my reminder code. But there it is. There's that notification that we triggered 10 minutes ago. Okay, so yeah, concretely, you click the reminder button. We hit this schedule notification. There it is. Schedule reminder endpoint. That queues a message. We generate a unique ID so that it's deduplicated. We schedule it at a particular time. That goes into the QStash queue. At some point in the future, that message is deliverable. They call back into our process reminder routes, and we actually deliver the notification to Farcaster. So that's the whole kind of end-to-end flow. Okay, thing two is Yoink notifications, right? So you'll notice when somebody yoinks the flag from me, you get these notifications saying you've been yoinked. You can go back and look at the repository history if you want, but we had a few ways to do this and have evolved this towards using a background job, which has worked pretty well for this. Previously, we actually had it. This was pretty hacky, but we had it in the recent activity endpoint here. So this is loaded to get all the details about recent activity when you load the page. And so every time anyone would open this up, we would check, hey, are there any new notifications to send and trigger it? That's pretty hacky though, and it also triggers a lot of duplicate notifications. We were just looking at the recent activity, right, and saying go trigger notifications. So if you're doing it that way, you need to like do a lot of accounting for like what's been seen, what hasn't been seen. You may be triggering a lot of duplicates. It's a little bit fragile, right? And also you're not sending notifications if nobody's opening the page. So we got away with it when we were prototyping the thing, but in production we need a more robust notification management system here. Um, and for Yoink notifications, like, real time is nice, but not critical. So what we have now is just a background job that runs once per minute. Here's what that looks like in QStash. We have a scheduled job. This is hitting this process notifications endpoint. And you can see there's a cron tab. Yeah, there it is. This cron tab, all stars, is run every minute. So this will run every minute and hit this endpoint. And this API route goes and looks for new yoinks that have happened on chain and triggers notifications for them. And yoink is a little funny in that the events we care about are on chain, right? Like there's no step in this workflow. I guess we could trigger this, we could trigger this from an API call or something after we get the successful callback in the app. That might be another design that could work for this too, which would be maybe a little bit more real time, but we need to think about the failure cases of when those API calls could fail too. So for this, I'm just like running a background job that looks for recent yoinks and triggers those once a minute. Which feels pretty real time. It's worked pretty well. Yoink is Yoink is just a game. So, but your use case may differ, right? If you want real time notifications, maybe you need to trigger these in a more real time way. Anyways, yeah, we're storing in Redis the ID of the last yoink that was processed. I won't go into all the details, but we built in the indexer a route that goes and gets recent activity, and we can page through that route based on the last one that we processed. So keep track of that somewhere in here, and then iterate over those yoinks and queue a notification for each of these. So unlike that other message, these are delivered immediately. We're not scheduling these, but these do go through the job queue. And that gives us the messaging properties that we want from using the job queue, meaning deduplication and retries. So here's the message ID. We're using a unique ID here. I think it is this is the ID from the indexer, which is just the ponder default ID. I think that is the block hash and the block position of the event. So that'll be unique per yoink. And then we use this message ID for deduplication and idempotency. And then the message queue can also handle retries, right? So if this fails, we have a retry policy. I think it's 3 retries configured by default. Cool. That's how yoink notifications work. The other end of the queue, right? So this is the end queue. When these messages are actually processed, we hit back to process yoink. So we'll get back to the body of that enqueued message, and we can use the yoink ID and the information that we encoded in there to send this notification. So really similar pattern. Check if we have a valid token. If we don't, skip it. If we do still have a token, try to send the notification. A couple things I'm not doing yet, or we could be doing better in here. One is I'm not yet consuming the valid, rate limited, and invalid tokens out of this response. So this response does give us back a nice response that includes which tokens were invalid and which tokens were rate limited. And so to make this even more robust, we would want to read those out of here and handle those differently, right? So it may be the case that we lost, maybe we missed a message over the webhook. And so we didn't know that one of these tokens that we still think is valid is out of sync with Warpcast and has been revoked by the user. This is one way we can recover from that, is by looking at those tokens out of here. So probably we should have a block in here that says, iterate over this tokens we get back in this response and handle them in various different ways. The other thing here is rate limiting it could be a little better here, right? So you may get rate limited by webcast. Really, we should retry those specific tokens. Actually, in this case, it's just going to be a single token, right? We know that this isn't a batch message, so there will only be one. So it'll only be rate limited, revoked, or successful. We are just throwing here, which causes the queue to retry in the case of a 429. But really, we probably want to reschedule, right? So we could handle this in a more robust way, rather than just retrying based on the retry policy, which I think by default is like some exponential backup policy. We should actually be a little more robust about like thinking about how we should handle those rate limits. So we'll probably add that to Yoink as I continue working on this. The other thing here is that like there's just a default, right? So sort of catch-all error handler. If anything else happens, we throw, which signals to the queue to retry it up to n times whatever is configured in the queue. Yeah, and point here and using messaging. This is all stuff you need to like build yourself. You can do it yourself if you just want to use raw Redis or something. That's how Yoink started. It worked fine for a couple days, but in most cases, probably a good call to use a slightly more robust system that handles some of those deliverability and messaging guarantees out of the box. I haven't looked at chat in a sec. Let's see. Cool. Nothing new. Okay, last thing here, the webhook route. So yeah, we looked at the route for triggering a scheduled notification, which uses this Qstash scheduled message. We have a background job defined. I guess I didn't look at how we're defining that job. Where is this? Just have a little script here that sets this up at deploy time, which just creates that scheduled every minute process notifications job. And like with every message, this has a unique ID too. Like every message in your system, give it a unique ID. If we don't do this, it will create a new one on every single deploy. Oh, yeah, if you do choose to use this particular tool, by the way, yeah, a couple like little gotchas that I found. Your deduplication IDs can't have colons. So I was already using these Redis keys. We migrated it from Redis keys that had colons. So it needed to replace these with underscores or some other separator. So it was a little hacky, but right now, just taking these IDs, which I preferred with these colons, and to convert it to a deduplication ID that Qstash can use, it needs to use some separator that's not a colon. Yeah, and I'd say the other one I found was relying on explicit message IDs, explicit deduplication IDs, rather than content-based deduplication proved to be more successful for me. I think there are probably some bugs in my implementation as I was working through it, but it can do this content-based deduplication out of the box, where it just like hashes your JSON data and based on the attributes in your data, tries to generate a unique deduplication ID, which is kind of cool and nice if it just works for you out of the box. But explicit IDs were better for me. We had some cases of duplicate notifications. Okay, last thing is the webhook, right? So how are we handling notifications and messages that come in over the webhook? So here's our webhook route, API route. I would recommend that you go grab the webhook route out of the V2 demo app. I did this one myself, and Chris's code is a lot better. And soon we will have this packaged into the Frame SDK too, so you'll have to do none of this. But we can just walk through this, right? So here's the webhook route. Looks pretty similar to the demo route. we are grabbing the signature out of this request body, decoding that Farcaster signature header, doing a bunch of base64 decoding, and then encoding into a buffer here, grabbing the payload data out of here, decoding that. Here's signature verification. Some of this is like munging out of base64 into hex, lopping off the 0x at the beginning of the hex, verifying the signature with this ED25519 library. Just use the version of the demo app. Here's an alternate way you can do verification. I guess you do what you know. So I know the smart contracts, so I did it by verifying from the smart contract. So we're looking in the key registry. So here I'm setting up a VM public client for Optimism, and then reading the contract data, right? So we can go get this, call this key data of method with the user's FID and the public key that came from that signer. So this will just check, is that on chain right now, stored in the key registry? If we get back the right result from this, truthy value from this, then it's valid. For most devs, I think the solution we have in the demo app, which uses Nanar, is probably simpler. But you can do it this way if, for whatever reason, you don't want to use Nanar. You can do this. I would recommend you use your own transport here, your own endpoint. I'm just using Optimism. Okay, and then handling those webhook events, right? So if a frame is added, we're saving the notification token we get back. If a frame is removed, we're deleting the notification token. If notifications are enabled, we're adding the notification token. If they're disabled, we delete the notification token. Okay, that's the walkthrough for Yoink. This code base is on my GitHub, github.com/horsefax/yoinkdevcon. The demo app is on the Farcaster GitHub, Farcaster XYZ frames v2 demo. What did we do? We took a look at Yoink. Yeah, go check this out. This is all live in Warpcast. So if you want to try out some frames, tap this frames tab at the center, tap into explore. You can find Yoink and try it out and sort of see what the UX is of these notifications. You can trigger a notification to yourself if you Yoink the flag, or trigger a reminder through here. Or just go use the demo app through the dev tools. I'll just trigger from here, but you can find that in the dev tools, and you can trigger notifications to yourself to just test it out. We talked over kind of the core concepts with notifications. So you can get, you need a notification token in order to send notifications to the user. You can get that either through interacting with the SDK when the frame is open, or out of the context, right? When a user lands in your frame, potentially you can get a token out of there. So there's sort of front-end tools you can use to access that token. You also want to set up a webhook so you can handle the kind of closed path when users are adding or removing your frame outside of when it's open in the client. So set that all up in order to handle notification token related events. Talked over basic principles for handling notifications. You want to make sure they're idempotent and deduplicated so you can avoid annoying your users with multiple duplicated notifications. Also think about edge cases, retry policies, failure modes in terms of notifications, as well as just outside of the technical implementation. Be, I think, considerate and thoughtful in the way that you use notifications to demand user attention. They can always remove your frame and prevent you from sending them anything else. So use that power wisely. There's a notification guide in the Farcaster docs. Find those at docs.farcaster.xyz under frames. There's a sort of full guide to everything we talked about here that you can go take a look at. You can view the demo app code to see a simple end-to-end example of how to set up notifications. And then if you want a more complex application with a little bit more going on and worse code, go look at Yoink, the one that I did. Yeah, if anyone is still around in chat and has questions, I'll hang out for another second. I'm going to check on Farcaster too if any questions came up. But I think otherwise we will call it there. One question from Farcaster is like whether this is all code based right now, which I think is getting at like, do you still need to write code to do any frames v2 stuff? And yes, for now. I think in the next weeks and months, we'll probably have no code builders for frames v2. But yeah, right now, if you're building a v2 frame, you're probably going to be deep in the code. We are kind of like high level. We are targeting a stable frames v2 release early next year, where it'll all be, we'll stop shipping breaking changes too frequently and be a little more consistent and thoughtful about stabilizing the API and making sure we're not making those changes right now. So yeah, if you're choosing to build on frames v2 now, you're kind of opting into this is going to be a little unstable for the next few weeks, probably through end of the year. And then early next year, we're going to get it stabilized so people can really rely on it and build on it with confidence. Okay, yeah, I think that's the only question. Thanks, everyone. Please enjoy yoinking.